Hi everyone, welcome to My Max Academy. In this video, we'll continue with pair of linear equations in two variables chapter for 10th standard CBSE mathematics. We'll continue on example 15 in page number 61 in your textbook. So page number 61, example 15. Fine. So what is example 15? It says for which value of p does the pair of linear equations given below has unique solution. We need to find what value of p the given set of equations have unique solution. So what is the set of equations that is given in example 15? The equations are 4x plus py plus 8 equal to 0. Now 2x plus 2y plus 2 equal to 0. So this is a given set of equations. Now for what value of p this set of equations will have unique solution. Now what is the condition for unique solution? We have to go to our table 3.4 page number 46 in your textbook. So all of you go to page number 46 in your textbook. There's a table that is given which is table 3.4 in page number 46. There you can see the different conditions for different solution. Like for unique solution, a1 by a2 is not equal to b1 by b2, and for infinitely many solution, a1 by a2 equal to b1 by b2 equal to c1 by c2. Hope you all are looking at the table 3.4 in page number 46 in your textbook. And for no solution, the condition is a1 by a2 equal to b1 by b2 not equal to c1 by c2. Now here this question talks about unique solution. So what is the condition for unique solution? So condition for unique solution is condition for unique solution as per the table in 3.4, table 3.4 in page number 46 in your textbook. The condition given is a1 by a2 should not be equal to b1 by b2. a1 by a2 is not equal to b1 by b2. Now let's try to find what is a1, what is a2, b1, b2, right? So what is our general form of linear equation in two variables? It is a1x plus b1y plus c1 equal to 0, a2x plus b2y plus c2 equal to 0. Now compare these two and then find the value of a1, a2, b1, b2. So what is a1 equal to? Compare this with this. No, so this is in this form. The given equation is in this form. The right side it has 0, right? So a1 is 4. My b1, compare this, b1 is p, and my c1 is, compare c1 with this 8. Now a2 is 2. Comparing this coefficient of x in the second equation. So this is your first equation. This is your second equation. Here this is the first equation. This is the second equation. So compare second equation with second equation. My a2 is 2. My b2 is 2. b2 is 2 and my c2 is also 2. Now we need this condition because it says for what value of p the given set of equation has unique solution. Unique solution means this is a condition as per the table that is given in table 3.4 in your textbook page number 46. This is the condition for unique solution. Now what is a1 by a2? So a1 by a2 is not equal to b1 by b2. This is a condition for unique solution, right? A substitute. So this is there. This is true because they have said it is unique solution. Unique solution means this condition is satisfied or must be satisfied. So now what is a1 substitute? a1 is 4 by a2. a2 is, a2 I didn't write. a2 is 2. Sorry. This is a2. a2 is 2. Right? a2 is 2 is not equal to b1. b1 is what? P. b1 is the coefficient of y in the first equation. What is the coefficient of y? What is before y? P. So here before y we have b1. So this b1 is p. So b1 is p. That's why I wrote b1 is p. So p by, we have to find the value of p only. For what value of p? It will have unique solution. So p by b2. b2 is 2. Right? Now, so what do we get? So if you cancel these two, you get 2. You get 2 not equal to p by 2. Now this 2 will go here, cross multiply. Right? So this 2 goes here. It will become 4 is not equal to p. This 2 will go here. It will become 2 into 2, 4. 4 is not equal to P. So which means P is not equal to 4. When P is not equal to 4, it will have unique solution. So for what values of P means, we will say all values of P except 4, we will have unique solution. So for all values of P except 4, because P should not be equal to 4, because if P is 4, then this condition will not be satisfied. So P should not be equal to 4, which means the P can be any other value. P can be 1, 2, minus 1, 1 by 2, 3 by 7. P can be anything except 4, because P should not be equal to 4. Only then we will get unique solution. So we will say all values except P is equal to 4, the given pair of linear equations will have unique solution. Right? All values of P except 4, we will get unique solution. Fine. Now let's go to example 16. Example 16, important problem. Example 16 is an important problem. So what it says is, for what values of K will the pair of linear equations will have infinitely many solutions? So what is the equation that is given? Equation that is given for 16th example is kx plus 3y minus k minus 3, and this is in bracket, minus of k minus 3 equal to 0. Then 12x plus ky minus k equal to 0. Right, so we have to find the value of k for which the following pair of linear equations will have infinitely many solutions. Now for infinitely many solutions, so condition for, what is the condition? So condition for infinitely many solutions. What is the condition for infinitely many solutions? We have to refer our table 3.4 in your textbook, page number 46, table 3.4. Refer that and tell me what is the condition for infinitely many solutions. So we need to remember those conditions. Obviously we can't refer the table in the exam, right? So I'm telling you so that you can go and refer in the textbook, but you should be already knowing that. If you don't know, please go and see that table, understand that, or watch my previous videos. So condition for infinitely many solution is what? This is the condition: a1 by a2 equal to b1 by b2 equal to c1 by c2. So this is the condition for the given pair of linear equations to have infinitely many solutions, right? So which means for this condition, what should be my value of k? What is the value of k so that this condition is satisfied? That is the question. We have to find the value of k where this condition is satisfied, which is the condition for this given set of linear equations to have infinitely many solutions. Okay, now let's identify what is a1, a2, a3. So what is a1? So whenever you want to check the condition, you want to make sure that the givens, whenever we are going to check this condition, we need to make sure that the given set of equations, it is in this form. It is in the general form. This is a general form of linear equations in two variables. So which means the right side should be 0, yes, and everything should be on the left side. That's the only condition. So now this is in this form. Now compare this and find the a1, a2. This is equation 1, equation 2. What is the value of a1? a1 is the coefficient of x. What is before x? K. That is a1. Before x is in the first equation, coefficient of x is a1. So we have to go to the first equation. What is the coefficient of x? K. So a1 is k. What is b1? b1 is coefficient of y in the first equation. b1. b1 is 3. Compare this. This is b1. b1 is 3. What is c1? c1 is, you have to be careful. C1 is what? Don't write k minus 3. You have to take along with the sign. There we will make mistake. We'll just write, you'll write c1 as k minus 3, then gone. It's wrong. You have to take, always you have to see along with the sign. See here I'm just writing 3 because it is plus 3. If it was minus 3, I would have put minus 3 here. Since it is plus 3, I have put plus 3. If it was a minus 3, I would have put a minus 3 here. Right? You have to always take with the sign. So this is C1 is what? Minus of K minus 3. That is your C1. Minus, then bracket. That's how the question is. Minus of this whole thing along with the sign is C1. C1 is without X or Y. Now here, what is A2? Coefficient of X in the second equation. What is that? 12. What is B2? K. What is C2? K? No, it is minus K. What is C2? It is minus K. You have to take along with the sign. So here for B1 or B2 whatever, don't put KY. You have to write only the coefficient of Y. Only coefficient of Y is what? K. Only K you have to write. Don't put Y. Here don't write 3Y. Or some people will put 3. I mean some people will put Y. Or they'll put 3Y. Both are wrong. And just only take this is your A1. This is your B1. This is your C1. This is your A2, B2, C2. I am again telling this because I have seen students making mistake while taking the coefficients. They don't take along with the sign, or they take along with X. They will say A1 as KX, B1 as 3Y, or they will say A1 as X, B1 as Y. These are incorrect. You just need to take the coefficients and we should take along with the sign. And for C1 and C2, it is the constant term, which means it should not have X or Y. The entire thing. Don't say only K or minus K. The entire thing, the remaining entire thing is C1 here. This entire thing is C2. You just need to compare this with this and write it. Fine. Now let's substitute all this in this one. Right. So what do we get? A1. A1 is what? K by A2. A2 is what? 12. Equal to B1. B1 is 3 by B2 is K equal to C1. C1 is minus of K minus 3 by C2 is minus K. Fine. Now we need to solve this and find the value of K. So to solve this, we are, whenever you have three ratios, you have to take first these two. Let's take these two and solve. Then you have to take these two and solve. Or you can take any two, this and this and this and this, or this and this, any two pairs. You have to take and solve. Any two pairs. This is one pair, this is one pair. So we'll take these two and then we'll take these two and solve. Right? So first we will take the first pair. So I will erase this. So what do we have? Here we have K by 12 equal to 3 by K. I am taking this first, these two first. Then solve. So cross multiply. K into K is K square equal to 12 into 3. 36. So this into this equal to this into this. Now K equal to plus or minus square root of 36. Whenever your square goes this side, it will become root. You should always put plus or minus. You have to remember that. Whenever you have x square equal to a, means x is equal to plus or minus root a. Don't just write x is equal to root a. Don't write like this, x is equal to root a. When x square equal to a, don't write x is equal to root a. X is equal to plus or minus root a, which means x will be plus root a or x will be minus root a. Fine. Anyway, so now, so k is equal to plus or minus, what is the root of 36? Which is 6. So which means k is equal to either 6 or k is equal to minus 6. That is the meaning of this. K plus or minus 6 means either k is 6 or k is minus 6. Right? Now let's try to check the other condition. These two. Let's equate these two. Right? So we have got, for these two, we found the value of k is either 6 or minus 6. For these two, we should find what is the value of k. Because that k should satisfy all these three conditions. So we'll take these two. We'll equate these two. What is that? 3 by k equal to, so don't stop here and say, okay, I found the value of k, k is 6 or minus 6. The problem doesn't end here. Because you have verified only these two conditions. Which means you have verified only this. You need to verify this also. Because this condition also must be satisfied for the given set of equations to have infinitely many solutions. So we need to take these two and check. right? So what is that? So 3 by k is equal to minus of k minus 3 by minus k. So minus minus will get cancelled, right? So k into 3 is 3k. This is k into k minus 3. So you get k into k minus 3. You can multiply. This k will go here. It will become 3k. This k will go here. It will go to the numerator. So k into k minus 3. So you get 3k equal to k square minus 3k. Right? Now, if we solve this now, which means I am going to take this side. So I'll get 0 equal to k square minus 3k. This 3k comes here. It will become minus 3k. Plus 3k comes this side. It will become minus 3k. So you will have 0 equal to k square minus 6k. This can be written like this, k square minus 6k equal to 0. Always make sure that you keep your variable, the one that you are going to find, either k or p or x or whatever. Whatever you are going to find, it should be on the left side. Your number should be on the right side. Always keep that. If you get like this, you interchange. The whole thing can be written here, 0 will go here. Now, here we need to solve. So take k common. Then you will get k minus 6 equal to 0 in these two. If I take k common, this will become k, and this 6k I have taken k out, it will become 6. So if you multiply k into k square, k into minus 6 is minus 6k, you will get back. So which means you will get either k equal to 0, either this equal to 0 or k minus 6 is equal to 0. Which means k equal to 0 or k is equal to 6. So in this condition we got k equal to 6 or k equal to minus 6. For this condition to be true, I should have k equal to 0 or k equal to 6. Now which number is common? Which k is common here? What value is common here? Both have to be satisfied. For what value of k, both will be same. K equal to 6. Because that is what is coming in both. K equal to 6, here also k equal to 6. So the answer is, so we have to see which value of k is present in both. This condition also should be satisfied. This condition also should be satisfied, means k equal to 6 is here, also k equal to 6 is here. So which means we cannot take this value. K equal to minus 6 will not come. Or k equal to 0 will not, because k equal to 0 will satisfy only this, but it is not here. And k equal to minus 6 is here, but it is not here. But which value is present in both the places? K equal to 6. So the answer is, the value of k, answer is k equal to 6. So for k equal to 6, then this set of equations will have infinitely many solution. Right? So for answer is k equal to 6, this set of equations will have infinitely many solutions. Clear? Now let's go to exercise 3.5, page number 62 in your textbook. Right? So I will start here. So we'll say page number 62 in your textbook, exercise 3.5. We'll do exercise 3.5. Fine. In page number 62. Okay. So what it is? So the first question. Let me erase all this. Okay, first question is, which of the following pair of linear equations has unique solution, no solution, infinitely many solution? Which means we should check the ratio. In case there is a unique solution, find it using cross multiplication method. So the question number 1 is, they have given equations. We have to take the equation and check whether it has unique solution or no solution or infinitely many solution. If it has a unique solution, then we need to solve using cross multiplication method and find the solution. Solution means we need to find the value of x and y. So let's take the first equation that is given, first set of equation. So in first problem, first sub problem, which is x minus 3y minus 3 equal to 0, 3x minus 9y minus 2 equal to 0. Now we need to check whether this given set of or given pair of linear equations has unique solution or no solution or infinitely many solution. If it has unique solution, then we have to solve using cross multiplication method. So first let's write what is our general form of linear equations in two variables. a1x plus b1y plus c1 equal to 0 a2x plus b2y plus c2 equal to 0. This is a general form of linear equations on two variables. So whenever you need to check whether it is unique solution or infinitely many solution or no solution, you have to make sure that the given set of equation is in this form. If it is not, you need to convert in this form. You need to convert them in this form. So here it is already in this form. The right side equal to 0, right side equal to 0. Now we should find what is a1, a2, a3. Oh, sorry, a1, b1. So a1 is what? a1 is a1. It is 1. The coefficient of x in the first equation. This is first equation. The second equation. Here this is first equation. This is second equation. Right. So coefficient of a1 is 1. What is b1? b1 is 3. No, it is minus 3. Minus 3. You have to take with the side. Right. What is c1? c1 equal to 3. No, it is also minus 3. Okay, this is a1 is 1 because nothing is there means 1 is there. If I write x means it is 1x. So a1 is 1, b1 is minus 3, c1 is minus 3. Now what is a2? a2 is the coefficient of x in the second equation. Second equation we have to compare second equation of this with second equation of this. a2 is 3, b2 is 9. No, minus 9. b2 is minus 9. What is c2? c2 is minus 2, not 2. Don't say c2 as 2. c2 is minus 2. b2 is minus 9. Right? b2 is minus 9, c2 is minus 2. Now let's check whether it has unique solution, or for that we have to check the condition which is in the table 3.4 in page number 46 in your textbook. What is the condition? Let's find what is a1 by a2. We need to find the ratios. What is a1 by a2? 1 by 3. What is b1 by b2? What is b1 by b2? b1 is minus 3, b2 is minus 9. That gives me 1 by 3. If you cancel, minus minus will get cancelled, then 3 ones are 3, 3 3s are 9. Now a1 by a2 is equal to b1 by b2. Now let's find what is c1 by c2. Because whenever your a1 by a2 equal to b1 by b2, you should continue to find c1 by c2. Suppose if they are not equal, here it is 1 by 3, here it is some minus 3 by 7 or whatever, or 2 or whatever. If they are not equal, then you need not find c1 by c2. You will just say a1 by a2 is not equal to b1 by b2. It has unique solution, then you will try to find a solution. But here a1 by a2 equal to b1 by b2, both are 1 by 3, 1 by 3. The moment both becomes 1 by 3, 1 by 3, both are equal, then you need to continue to find what is c1 by c2. So based on that only we can see, when these two are matching, we can say definitely say it does not have unique solution, because the unique solution condition has failed. Unique solution condition is what? a1 by a2 should not be equal to b1 by b2, but here they are equal. So which means we should continue to find what is the ratio c1 by c2. What is c1 by c2? c1 is minus 3 by minus 2, which is 3 by 2. Now what we have got? a1 by a2 equal to b1 by b2, but it is not equal to c1 by c2, because it's 1 by 3, 1 by 3, but this is different. These two are equal, but it's not equal to this. So therefore we get a1 by a2 equal to b1 by b2, but it is not equal to c1 by c2. It is not equal to c1 by c2. For this condition, what can we say? Let's refer, or you should be knowing, or if you don't know, refer the table 3.4 in page number 46 in your textbook. As per that, for this condition, it has no solution. When a1 by a2 equal to b1 by b2 not equal to c1 by c2 means no solution. So which means the given set of equations, they do not have any solution. So we need not proceed further. We'll stop here, because only if it is unique solution, we need to solve them using cross multiplication method. That is the question. But here it is not unique solution. So which means we should stop here and say it has no solution, and we'll stop the problem. We cannot solve because it does not have solution. Fine. Now let's go to the next one. Let me go to the second problem. Can I erase this? I'll erase this. Fine. So what is the second problem? So second problem is, oh sorry, not the second, second subproblem. First problem, second subproblem. The first problem, second subproblem. What is the question? 2x plus y. Right? So 2x plus y equal to 5. 3x plus 2y. 3x plus 2y equal to 8. 2x plus y equal to 5. 3x plus 2y equal to 8. Fine. So now we need to check whether it has unique solution or no solution or infinitely many solution. If it has unique solution, then we need to solve this using cross multiplication method. So again, let's check whether, first thing to check whether it is unique solution or no solution or unique or infinitely many solution, we should find these ratios and all that. So which means we should find a1, a2. The moment you need to find a1, a2, b1, b2, c1, c2, then the given equation should be in this format. Is it in this format? No, because the right side we should have 0, but we have 5 and 8. But right side we should have 0. So we should convert this in this form. So which means I will write this as 2x, first equation, second equation, 2x plus y minus 5 equal to 0. The 5 has come this side, so minus 5. Then 3x plus 2y equal to 2y minus 8 equal to 0. So we have now converted the given set of equations in this form by bringing everything to the left side, one side, and right side is 0. Now this is in this form. Now let's compare these two and let's write what is a1. What is a1? a1 is 2, b1 is 1. Don't write y. People will write if then nothing is there, then 1 is there. But if it is y and if it is b1, I have seen people writing b1 equal to y. Now b1 is 1. You should not write y or x here. You should write only the coefficient of x and coefficient of y. So b1 is the coefficient of y in the first equation, which is 1. Y means it is 1y. Now c1 is what? 5 minus 5. Now a2 is 3. b2 is 2. c2 is minus 8 along with the sign minus 8. Now let's find what is a1 by a2. What is a1 by a2? 2 by 3. Now come on. Now what is b1 by b2? 1 by 2. So a1 by a2 is 2 by 3. b1 by b2 is 1 by 2. Therefore a1 by a2. You need not go and find c1 by c2. Where we did here. We did here because both were same. Both were same. So we had to find c1 by c2. But here both are different. a1 by a2 equal to a1 by a2 is not equal to b1 by b2. So we should stop. The moment you get a1 by a2 is 2 by 3, b1 by b2 is 1 by 2. They are not equal. They are not equal. Then we should stop. We should not find c1 and c2. It's a waste of time. Only if they are equal, then you will go and find c1 by c2. Say now here they are not equal. Therefore, this condition is satisfied. a1 by a2 is 2 by 3, b1 by b2 is 1 by 2. So a1 by a2 is not equal to b1 by b2. Therefore, as per the table 3.4 in your textbook page number 46, it has unique solution. So the moment it has unique solution, we have to proceed. We have to continue the problem and solve and find the value of x and y using cross multiplication method. So we will continue to solve this using cross multiplication method because it has unique solution. The earlier problem what we had was it was having no solution. It wasn't having any solution. So it was no solution. So we did not proceed and we did not try to find or we did not try to solve. We did not try to solve because there was no solution. But here it has a solution. It's a unique solution. So we will try to solve and find the value of x and y. To solve, we are going to solve using cross multiplication method. Right? Because that's what the book says. If it is a unique solution, solve by cross multiplication method. That's what the question says. Right? So we will try to solve using cross multiplication method. Fine. Now, how do we solve using cross multiplication method? So for the cross multiplication method, we have to make sure that the given set of equation is in this form, which is in this form, which is fine. Whenever you need to find a1, a2, b1, b2, it has to be in this form. That's the first thing. So, which means we have to refer this. We already know a1, a2, a3, all that. So if you need to solve this using cross multiplication method, what is the method? We'll write x, right? We'll write x, we'll write y, we'll write 1. Then we'll write b1, b2, sorry, c1, after b, c, c1, c2, a1, a2, b1, b2. So you need to remember this format you need to remember. You put x, y, 1, then here you write, you will start with b1, b, after b, c, After C, A, after A, B. Then B1, B2, C1, C2, A1, A2. So this is the standard format, or you can think this as a formula for cross multiplication method. Now let's substitute what it is. X, Y, 1. What is B1? B1 is 1. B2 is 2. Then C1 is minus 5. C2 is minus 8. Right? C2 is minus 8. Then A1 is 2. A1 is 2. A2 is 3. A2 is 3. Then B1 is 1 and B2 is 2. Then we should say X by this into this, 1 into minus 8, 1 into minus 8, minus 2 into minus 5. So this is a formula. This minus is a formula. This into this, and you should put minus this into this, equal to y by this into this, minus 5 into 3, this into this into this, minus this into this. I can put the sign minus if you want. This into this, minus this into this, right? So okay, this into this, minus this into this. So minus 8 into 2. So generally we'll miss minus, this minus. So this into this, minus you have to put, then you should do this into this. Before putting minus, don't do this into this. Clear? So similarly, equal to 1 by, you should put this into this, 2 into 2. Then immediately you should put minus. Then you should do this into this, 3 into 1. Clear? Everyone? So this into this, minus, then you should do this into this. Equal to y by, first you should do this into this, minus 5 into 3. Then immediately put minus, then you should do minus 8 into 2. So here you will miss minus. Double minus is coming. You have to be careful. This minus 8 is this minus 8. This minus we always put. When the moment you do this into this multiplication, you should put minus and then do this into this. Then again 2 into 2. Minus, then you should do 3 into 1. After putting minus only, you should put 2, 3 into 1. Right? So now this becomes x by minus 1 into 8 is minus 8. Minus 2 into minus 5 is plus 10, equal to y by minus 5 into 3 is minus 15, minus into minus plus 16, equal to y by 4, 2 to the 4 minus 3. So you get x by 2 equal to y by 1 equal to y by 1. Sorry, this is not y, I'm sorry. 1 by 4 minus 3. So which means 1 by 1. Fine. X by 2, because minus 8 plus 10 is 2, minus 15 plus 16 is 1, and this is 1 by 4 minus 3 is 1. Now we should take these two ratios first, then we should take these two. To find x, you will take this and this. To find y, you will take this and this. Fine. So I will do here. I will continue to do here. Fine. So now we will take this x by 2 equal to 1 by 1. X by 2 equal to 1 by 1. So 1 by 1. So 1 into 1. 1 into x is x equal to 2 into 1 is 2. So x is 2. If I compare this and this, I have taken x by 2 equal to, don't put this is equal to this. We won't get the answer because x this is y. We won't get the answer. Clear? So x by 2, 1 by 1. Then put y by 1, 1 by 1. Equate these two. Y by 1 equal to 1 by 1. So y by 1 equal to 1 by 1. So 1 into y is y. Equal 1 into 1 is 1. So y is 1. So solution is, or the answer is whatever. In this solution or answer is x is equal to 2, y is equal to 1. So we have solved this and we got the answer using cross multiplication method. So I would say you can try the third and fourth problem. I mean in the first subdivision we have done in the first problem, first subproblem and second subproblem. You try to do the third problem in the third problem and in fourth subproblem. These two you try to do the same way. You have to check the ratio and then see whether it is a unique solution. If so, you have to solve using cross multiplication method. Fine. So you can try these two, and if you have any questions, you can WhatsApp me and I will try to answer as much as possible. Fine. So we will continue on the next video. So please watch my next video for the continuation of this. Thank you for watching, guys. See you in the next video.